transformation of nonlinear data. And this circle of transformation, I obtained this circle from the Cambridge textbook. So this is in there. So it's better to have it in your reference book. All right. Now, if the original data after you sketch, after you graph using your CAS, looks like more of this, the points are more of that. So these are the possible transformation you could use. If the points are more of that, if it forms a shape more of this that looks like this, you could use this. These are the possible transformation you could do to make it linear. Having said that, the square, the x square, the y square, they stretch the data to make it linear, whereby log and the reciprocal of x and y, they compress the data to make it linear. All right, let's have a look at an example based on this concept of stretch and compress. So this is an exam question, which is exam 1 2016, question 11. So the table, this table gives us the human development index and the mean number of children, and so this is more of like that. So all the points are more of that shape. So if we go back to our circle, so it's more of this. So we could use one of this. So we could either use the log of y, the inverse of y, or log base 10x, the x values, or the inverse. So any of this, they compress the data to make it more linear. So it's more of that. So to do so, we have to use our CAS. So let me change my screen to CAS. All right, so this is my CAS. All right, I've entered the data before. So this is my data. So to compress that, so just tap there. So we're going to press Control, press the log base 10. So put the 10 there. The base is 10. So we're going to compress the children, which is the y. So there we go. So it's going to be ly, just to say log of y. So after you do that, we're just going to have to graph it and see how it looks. So we're just going to press Control, Dock, and select number 5. And we want to have a look. That's going to be the HDI. And that's going to be the log of y. So now this looks more linear than the one we have before. So to get the equation, so press Menu, Analyze, number 4, and number 6, and number 2. So there we go, equation. So the equation will be 1.1 minus 0.0095. So don't use the word x. So we're going to use an So our equation is log. So our log is base 10. So that was an 1.1 minus 0.0095 times HDI. So that's how you do the log. So this is one example. So we could, that's one option we could use to make this one more linear, or we could also use the compression, which is going to be done the same way, except that we're just going to have to say 1 over our y value are the children. So this is our y value. So just to make the children, so you don't have to do it again. So you can just get another column using the same CAS, and it's going to give you the same sort of results. Well, the equation will be different, but it makes this more linear, this curve. All right, that's the end of transformation.